So good morning, here is today's lesson for you, and as I said on Friday, we're looking at Corbett Maths Foundation 5 a day, and we're starting on 1st of May. Yes, there is method in my madness, as I was trying to explain, and some of you out there will know exactly why we've started on the 1st of May. So are the questions that are on that sheet. If you want to pause the video now, if you weren't able to find Corbett Maths sheet, please pause the video now, because I'm about to go through these questions. I have done a second version of these questions, so you may want to pause the video later anyway if you've already done these, but please pause the video now as I'm about to go through these questions. Okay, so let's go through those questions. The first question asked us to substitute a 6 for the value of x and a 7 for the value of y. So we end up with 5 lots of x and 3 lots of y. And 5 lots of 6 will generate 30, and 3 lots of 7 will generate 21, and that will produce an answer of 51. So we're substituting in the x and the y values, and then of course 5 of the x and 3 of the y, and then added together. In the second question we have an input which is 11. So we've got an input of 11, and there it is. We now follow the 2 steps. So it says 11, we add 10 to 11, so that generates 21. We then divide this result by 3, giving us an output of 7. And this is a lovely way of doing it in the exam, actually putting the input in and doing the first step and then the second step and generating both parts. For the reverse question, we have an output of 20 and we have to reverse it. So we have to divide by, instead of dividing by 3, we reverse that and we multiply by 3. So that gives us 20. So that when we go the correct way, when we divide by 3 this way, we get the result of 20. So reversing it, timesing by 3 to get 60. And then again, instead of adding 10, we'll subtract 10. So that will generate 50. We can again now check this. 50 add 10 is 60, and 60 divided by 3 is 20. So we reverse the functions as we work backwards through the function machine. Next question we're going to look at is the indices. We've got the second law of indices and the third law of indices here. And I'm just going to show you what I do with this first of all. I change that into its fraction form instead. And m to the power of 8 actually looks like this. It means m is being multiplied together 8 times. There's 8 instances of them. 1, 2, 3, 4, 5, 6, 7, 8. And we're dividing that by 2 m's that are multiplying together. So there's m squared, of course. M will divide into m once, leaving you with one lot of these, which is obviously m to the power of 7. And m will divide into m again once, leaving you with m to the power of 6. Those of you who know the second law of indices know that we can subtract the powers to generate the answer of m to the power of 6. For the third law of indices, well, first of all, square. Square means we have something that we're multiplying by itself. So what I'm trying to say is that is occurring. M to the power of 3 is multiplying to m to the power of 3. And that is what is happening there. If I then think about what this is, and then what this is, hopefully you can see that we have 6 m's multiplying together, giving us m to the power of 6 there. Again, if you know your laws of indices, you know you can multiply the powers if you raise to a power and then raise to a further power. I'm going to start with this question first, because the last question I feel definitely was a calculator based question, as you'll see in a second. Make m the subject of the formula. So if we're going to make m the subject of the formula, we need to get it on its own, and at the moment we have a divide by c. So if we mathematically remove the divide by c, we move it to this side of the equation, a divide by c becomes a times by c. I'll accept that, and of course I'll accept that, and I'm going to go for the latter, as that is the convention. But both are correct. I then rearrange that so that m is on the left hand side. So m equals c multiplied by s, but we never show a multiplication in algebra course because it looks like an x. So let's look at the final question in this Corbett Maths 5 a day. and we're trying to find the volume of this cylinder. So what we'll look at first of all is that the volume of any prism, and this is a cylinder is a prism because it has a constant cross-sectional area multiplying here. What I'm trying to say is there is a circle flowing throughout this cylinder that is constant. So the cross-sectional area is a circle, and we multiply that by its length or by its height, and that is the formula for a prism. So in this case, of course, with it being a circle, I end up with the area of a circle multiplied by its height here. So now I have to find the area of the circle, pi r squared. The radius is given as 3, so the area becomes pi times 3 squared. 3 squared is 9, of course, so we end up with 9 pi. As I said, this is a calculator question, and if we perform that function on the calculator, shift to get pi, that might be a little bit different on the calculator you're using, but pi for me is a shift and the legacy standard form button there. And then we multiply that by 3 squared, and as you can see the calculator throws back at you 9 pi. Keep it in terms of pi. If you've got a decimal answer of 28.27, that's fine, as long as you use the full answer, that is fine, but I'm going to keep it in terms of pi, and you'll see why. So the volume now, the cross-sectional area, the circle, is 9 pi, and the length, or the height in this case, is 2.5. So my volume is 9 pi multiplied by 2.5. I do press the ST button this time, and I get 70.6858341. Now we weren't told what to round to, I don't believe. Let me have a quick check. No, we weren't, so we'll go to 3 significant figures. That seems appropriate in this case. So 3 significant figures, so 1, 2, 3, rounding number. So 70.6 or 70.7, well, I don't make that decision, you don't make that decision, the rounding number makes the decision, and in this case that 8 is larger than 5, so rounds us up. 70.7, and that would be centimetres cubed, of course, because it's a volume we're finding. So they are the questions that were set for you from the Corbett Maths. What I've done now is to do a version 2 of those questions, and you're likely going to want to pause the video now so you can actually have a go at these now. You can of course come back to them, so if you want to do these later in the day, just come back to this point in the video, and I believe it's coming up to about 8 minutes in the video where I will go through them. So I've changed the questions slightly. They're based very similar on what you can see what the 1st of May was done as well. So I'm going to go through them in a minute. So if you want to pause the video now. Okay, let's go through those questions. Actually, I'll just go back to them because I need to know what the output and the input are for the questions. So we've got an output of 75 and an input of 12, that looks like. So let's go through these questions now. Find the value of 5x plus 3y when x is 8 and y is 9. So very similar to what we just did a minute or two ago. I've got a value of 8 that gets substituted in for x, and a value of 9 that gets substituted in for y. 5 8s are 40, 3 9s are 27, and I add them together to get 67. Very well done if you got that the second time round. The input and output questions, so an input of 12, we add 5 to that to get 17, and then we multiply 17 by 3. That's not the easiest of multiplications. So 10 3s and 7 3s is a nice way of getting around that without calculator. 10 3s generate 30, 7 3s generate 21, add them together to give 51. And this is a classic question. If you've been in any of my classes over the years, you'll know I always ask, is 51 a prime number? And the answer of course is no, because 3 and 17, as well as 1 and 51 of course, are factors of 51. So there's a classic question. Is 51 prime? The answer is no. Okay, so looking at the one here, 75 is our output. We're going backwards this time, remember. So instead of multiply by 3, we're going to divide by 3. And 75 divided by 3 is 25. Again, if you work it this way, you can see it's going to work. 25 times by 3 is 75. We're working backwards here. We're not going to add 5, we're going to subtract 5. and 25 subtract 5 is 20. So it was an input of 20, add 5 is 25, times by 3 is 75, and it's that lovely check again to make sure your answer is correct. So there's the answer we're looking for there, and there's the answer we're looking for there. Into our laws of indices. I think you know what I'm going to do. I'm going to set this out in its fraction format. There we are. So 6m to the 5, 6m to the 5, and 2m to the 3, 2m to the 3. 6 divided by 2 generates 3. Let's get that out the way straight away. M goes into M once, leaving you with one lot of this. M goes into M once, leaving you one lot of this. And M goes into M once, leaving you one lot of this. And of course, M times M is M squared. Again, if you know your laws of indices, the subtract has worked again to generate that M to the power of 2. Here I am cubing this number, which means I'll have 3 of them. And here they are. That of course then generates the following. If you look across there, you can see there are now 4 m's multiplying to 4 m's multiplying to 4 m's. I think you can all see there are 12 m's multiplying together. Very well done if you got that question. Again, if you know your third law of indices, we're raising to a power and we're raising to another power, so we can multiply the 2 powers to generate the answer. I'll do the rearranging question again first before we move to the calculator question. This is quite a tricky one, this one, and there's a number of ways of doing it. So if you don't like the way I've just done it, don't worry, and you've got the right answer, well done. But watch how I manipulate the maths here. Make C the subject. So I'm trying to get C on its own, but it's on the bottom of a fraction. So if I move the divide by C to become a times by C, which was our answer for the first section of this video, I can now see, well, I'm going to draw it in, which I shouldn't do, but there it is. C is multiplying to S here. So now I can move the S away from the C. So by moving the C first, I remove it from the bottom of the fraction, from the denominator position. And now I can see that these two are connected by a function of multiplication. So times by S becomes a divide by S, giving you the answer. Very powerful in trigonometry that. If you've done any trigonometry with me before, you'll have seen that, and with the other maths teachers that I work with, you've seen that's how we manipulate it when we've got an unknown on the bottom of one of our trigonometry questions. So our final question, I tried to catch you a little bit this time by giving you the diameter, but let's go through the formula again. The cross-sectional area multiplied by the length of the height is the formula needed for the volume of a prism, and this again of course is a prism. So the first thing I need to do is find that cross-sectional area, which is using pi r squared, but because I gave you the diameter, you have to half that to find the radius. Yes, that was the only little extra bit I put in there just to keep you on your toes a little bit there. So the radius is 6. That's going to generate 36 pi, of course, and again I can check that on my calculator. Shift to get pi times 6 squared, and there is the 36 pi. Going to keep it in terms of pi. I'm going to move into the volume now. So 36 pi multiplied by 4.5, because that is the length, or in this case the height. So the volume becomes 36 pi multiplied by 4.5, and that with the SD button gives me 508.9380099. Let's go to 3 significant figures again. I should have said that we were going to do that. So 1, 2, 3, and rounded number. So 508 or 509. Again, the rounded number makes the decision for us. The rounded number is larger than 5, therefore we round this number up to 509 centimeters cubed. I hope you enjoyed those, and I hope it was useful having a second set of questions there for you to do. Same again next Monday. We'll be looking at, and I'll just check for you. Yes, we're going to be looking at 5-a-day foundation, the 2nd of May. And if you haven't got that sheet, please go to the Corbett Maths website. Here are the questions now. I hope you can see them. If you pause the video and zoom in a little bit, you should be able to see them. There's a median question, a range question. There's a nice question there with meters and centimeters, bearings questions, and the area of a compound shape, which we're going to be looking at on Wednesday. So Wednesday's video, we're looking at a compound area and missing sides as well. Thank you very much for watching this morning, and I'll see you on Wednesday for another Key Stage 4 video, and of course tomorrow for our Key Stage 3 videos. Take care guys, remember, stay in, stay safe, and thanks for watching.